Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 2316. Count unreachable pair of nodes in an undirected graph. And before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes before jumping into the solution. So let's get right into it. What problem is asking that you need to return the number of pairs which are unreachable from each other. That's simple, but let's understand with the graph what it really means. Over here 3, over here 1, 6. Let's see. Is 0, 1 reachable? No, you cannot reach 1 because they are in different component. This is one component, this is second component, and this is third component. Let me write with other pen. This is component, not the vertex. Yeah, so 0, 1 cannot be reached, or 0, 3 can be reached. No, it can also not reachable, and also 0, 6, it is also not reachable. What else? Let's take 1, 2 is not reachable, 1, 3 is also not reachable, 1, 4 is also not reachable, 1, 5. And why we are not taking 1, 0? Basically same thing, that's why. So we cannot reach 3, 2, 5, 4. 3, 2, 5, 4. Yeah, everyone is there. Also, let's take 2. With 2, you cannot reach 2, 3. And also 2, 6 cannot be reached. 1, 2 is covered. That's why not 2, 1 is not required. Next is 3. With 3, we cannot reach 3, 0 is covered. 3, 1 is covered. 3, 2 is also covered. 3, 4 is not covered. 3, 4, 3, 5, and I hope 3, 6 is also not covered, so we will use 3, 6. That's good. Now let's see with 4, where we cannot reach. 1, 4 is done, so 4, 1 is not. 4, 3 is also done. There is no 4, 6. So 4, 6. How many we have till now? 3. And this is 4, 7, 9, 10, 13, 14. Did I? 4, 3, 7, 2, 9, 10, 13. One more. 5, 5, 6, 5, 6. 5, 6. Else everything is covered. 6, 6. There is no 6. Yeah, there is 6, but 6 is covered in almost everything. 3, 6, 4, 6, 5, 6, 1, 6. 1, 6 can be reached, so that's why. So these are all the pairs that cannot be reached. Can you reach 0, 1? No. Can you reach 0, 3? No. 0, 6. 0, 6 can you reach? No. 1, 2? No. 1, 3? 1, 3? No. 1, 4? No. Similarly, you can see there are 14 pairs that are not reachable to each other. Why? Because they are in different component. So how to approach this? This much is clear, that we need to use BFS and DFS because we need to traverse. And one thing is for sure, that something should be related with the component. Why? Because these all are in one component, these all are in one component, and this one is also component on its own. So one thing is for sure, the vertex that are in component can be reached, and the vertex that are not in the same component cannot be reached. So that much is clear. So can we do something like this? We know total pairs, and we know pairs which can be reached. Let me write it. We know total pairs, and total pairs include pair that can be reached plus the pair that cannot be reached. This is true or not? Yeah, in total pair these two will be present. What we need? This one. How we can get this one? Total pair minus pairs that can be reached. And also it is easy to calculate this. Am I right? How? If you know we have 4 items. If you know you have 4 items, and you need to make a pair 1 2 3 4, and there is no permutation, means if there is 1 comma 2, so no 2 comma 1 is required. So you need 2 pairs and you have 4 different things. How can you select 2 pairs? 4C2 basic maths, or you can even use that formula n minus 1 by 2. This is same thing what it is written. Formula is something like this: n minus n factorial. Let me write it for you. NCR n minus r factorial. This is the formula. This can be converted to this. You can do yourself. n minus 2. So this much is clear, that we can count if we get the number of things that are inside one component. That is easy. How it is easy? While traversing the component, have a count variable in it, and when you keep on traversing you will get how number of members that consist the component, not sorry the component, how many members the component has. Sorry, I just got myself confused. So this is how we are getting it. So what we just have to do, how to find total number of pairs? Easy. Use total vertex that are present, you will get total pairs, and these pairs can be calculated by traversing the components one by one, and after that you can get the answer. So algo would be something like this: calculate the total pairs. How we gonna get total pairs is n minus 1 by 2. Similarly, calculate the pairs in component. Again do n minus 1 by 2. Let it be some y, let it be some x, and you will get the answer by x minus y. So over here, how many vertex we have? 7. So 7 minus 1 by 2, 6, it's 3, 21 total pairs. And if we have in this component, how many we have? 4, 6 pairs, 1 pair only, and this is not even a pair, so 7. 21 minus 7, 20 minus 6, 14. That is our answer. Let's get to our coding part and sum it up fast. So yeah, what we are doing, basically converting edges. It is given in this format. We are converting into adjacent matrix, adjacency list, not matrix. Very much basic thing. Pushing the edges, you know the drill, how to convert this 2D vector into adjacency list. Here we are calculating the total pairs, the visited. You know why visited is required, so that you can do not get into the loop when you traverse. Basic, we are traversing everyone because components, there are components. So other, for example, from 0 we can traverse 2, 5, 4, but from 0 we cannot traverse 1, 6. That's why we use loop over here. Also, if it is not visited, then only go inside. And what we are doing, we are sending a count variable. After traversal we will get our count. What count specify? The number of members this component has. And what we do, we just subtract it from the total pairs. You can even do add all them, and at the end while returning it you can subtract it, whatever you like. Let's go over the BFS, not BFS, DFS, depth first search. So over here what we are doing, basic DFS, mark visited 1, why count plus plus? Because every time we visit we increase the count, because that's how we are getting the number of members. That's it. Basic thing, we are accessing their adjacent. If that adjacent node is not visited, we again do the DFS call, basic DFS traversal. You know how it goes. The only thing that changes is this is plus and this is plus, and everything else is just basic DFS. So I hope I was able to make my intuition clear, and let's see if it is running or not. Submitting. Yeah, it is submitting. I hope I was able to make you understand my intuition and I helped in your problem solving. If I was able to, consider subscribing to this channel, liking this video and sharing with others. And you have to do what you have to do. So keep grinding. And you guys are awesome. See you in the next one. Bye bye.